So we need to find the value of t here. We've got our speed and time graph. Key thing is that the distance travelled is equal to the area under the graph. And I know that my distance travelled is 550 metres. So now I've got a little job to do to work out the area under this graph. So I can split it into different shapes. The area of that section there, got a triangle, half times base times height, so a half times 3 times 30. I've now got this area here, which is a trapezium. So half of the sum of the parallel sides. Well, that is 30 plus this length here is 6, isn't it? 630 plus 6 times the distance between them, which is 2. Okay, and finally this section up here, we have rectangle, and the area there would be base times height. So the base here is t minus 5 times 6 is our height. So if I put all this together, this here, 3 times 30 is 90, half of that is 45. Working out this one here, half times 2 is 1, times that is 36. I get this. So my distance is 550, and that's going to be these areas combined. So 45 plus 36 plus 6 times t minus 5. So now I've written that equation, I can solve that. I've got 45 plus 36 is 81. So 550 minus 81 is 469. That's going to be equal to 6 times t minus 5. Divide both sides by 6 and I'll get 78.16 recurring. T minus 5, add 5, I get 83.16 recurring is t, and I'm asked for to the nearest whole number. So t is 83 seconds to the nearest whole number. So again, stop and pause to read this question. Okay, so the new model includes air resistance, and that would have the effect of slowing down the parachutist, and so the time taken to reach the ground would be longer. Okay, so the new value of t would be bigger. It says, how would the new value of t compare with the value found? The time taken would be longer, but the value of t would be bigger. They're quite pedantic here, which is a bit annoying. So here we're looking for a statement about the value of t, and it wouldn't really make sense to say the value of t would be longer. That's not the language that we use. The time taken is longer, but the value of t, which is what we're asked for here, would be bigger. And note here, they don't actually give you any marks. They don't give you this mark for takes longer. All right. Okay, part E, one further refinement to the model, apart from air resistance, to make it more realistic. The main thing that springs to mind is that they'd asked us to use a value of G of 10. So using a more accurate value for G, e.g. 9.8 meters per second squared. There are a number of other suggestions that you could use, and here's the mark scheme. So lots of different acceptable answers there. Just be warned, be careful, 1 mark. It says any appropriate refinement of the model, but if you add in anything that's incorrect or irrelevant, you don't get the marks. So again, a little bit harsh to pick up that mark.